Hello, this is Paul from Foresight Tech. In this lecture, we're going to evaluate the definite integral using basic area formulas, like the area for rectangle, for triangle, and for circles, like that. I will give two examples here. And the first example, and if we know the graph, this is a piecewise function, right? Each piece is a linear function. 1, 2, 3, 4 pieces. And then under the curve we have areas, and then going to evaluate the A, B, C, and the D one by one. So we look at the first. And the first is going to find the area on the curve between the integral intervals from 0 to 2. Look at it. This means what? And the definition is this is the area under the curve, right? Under the curve between 0 and 2. If I highlight, so the first one is just here. If I highlight, is this. This is a positive area because it's above x-axis, right? This is A. Look at this area. We know this is a trapezoid, right? So we say this is easy. Just we use the trapezoid, the formula. Trapezoid, the area for trapezoid. So we're going to find, this is easy to find. Should be equals, I just put here. One side is 1, another side is 2, right? The sum times the height is 2, and then divided by 2. So what are we going to do? Is 1 plus, so this height, no, sorry, this height is 3, this height is 1, so 1 plus 3. And then times, this side, and the height is 2, so times 2, and then divided by 2, did the formula, right? Okay, and then do calculation, what do we get? So it's 4, the easiest, did the first. Let's look at the second. The second is to find the areas between 0 to 5. See, 5 is here. 0 to 5. Okay, so this is not a good shape, but we can cut this whole shape into two parts. The first part is from 0 to 2, right? The second part is from 2 to 5. So I highlight 2 to 5 like this. Okay, this is 2 to 5. Okay, 2 to 5 is also trapezoid. We know the size, we know the height, so we can find the area. So we also can find the area of the left. If I highlight a little bit more, see, it doesn't show the difference. This is the second. Okay, so we definitely can find. So how do you say? So this time, this we can cut into 2, so which means 2 trapezoid. This is 2 trapezoid. We can cut, right? Use the integral property we just learned before. Trapezoids. Okay, and then we know how to get. So if I put a little bit longer, the first is do integral from 0 to 2 f(x) dx. So the second part is from 2 to 5. So from 2 to 5 f(x), this is 2. Okay, and then dx. So we do calculation. So the first we already find is 4, right? See, from the first part we already find is 4. What is the second? Is trapezoid. We're going to find trapezoid. And this side is 1. This side is 3. So we do this. So it's 1 plus 3 times the height is also 3. Good. Then divided by 2. Okay, so this is the trapezoid. And then do calculation, we find out what is 10. Means that the first is 4, the second part is 6. Added together is 10. Okay, and then we move to the third. From 5 to 7. 5 to 7 is a triangle, right? This is easy. This is just a triangle, the shape. But be careful, this should be negative. Okay, why? Because this part, if I highlight this first, I highlight the triangle. As below x-axis, the height is always negative, so this is a negative integral. Okay, negative integral, so we're going to do calculation at this. Okay, so it's a negative always 1/2 times the bottom times the height. So it's times 2, right? And the times 3. See, and then do calculation. So you will get is negative 3. Good. Negative. So keep in mind this is a negative integral. Okay, negative integral. The last. So we're going to 0 to 9 this time. So the whole area. So we need to cut in pieces. Okay, 1 piece, 2 piece, and let me see. I think we can have it 0 to 5, the first piece. Why? Because we already find 0 to 5, right? 5 to 7 we already find. And the last piece is here. The last piece is here. I highlight the last piece. Okay. The last piece is what? Is trapezoid. We know how to find the area of the trapezoid. So 1 piece, 2 piece, and 3 piece. Okay. So we do this. We say we can do this. We can do 3 part. Okay. And then we can going to find 1 by 1. So if I write the formula, use the property is 0 to 5 is the first. Okay. The second is 5 to 7. Okay. The last is 7 to 9. Okay. This is the property. And then what we can do 1 by 1. The first 0 to 5 we already find is 10. The second 5 to 7 we already find is negative 3. What is the third? So the third first, here is negative. Okay, be sure this is negative because it's below. So what I'm going to do, I will use this, is a negative. Okay, and this is a trapezoid. Okay, I will do the same. One side is 2, another side is 3. So it's 2 plus 3. And then the height 7 to 9 is 2. So times 2. The over 2, this is the formula. And then, okay, so everything is here. Do calculation, what do we get is 2. Okay, that's the first. Okay, we're going to the second. So here, the second example, we're going to use a circle, okay, something. But first, we need a property. So this is the first property we're going to show. F plus g, two functions integrate together, we can separate into 2 integrals. Why this is true? I'm going to prove for you. So we're going to prove. So here I prove here is I use the red color. So go to the left to the right, go to the first to the second. So what do we shoot? I'm going to shoot this. Okay, and then prove this. So how to do a little bit small. Okay, a b f plus g, right? So I have to use the definition. So the limited definition is this: m approaching infinity. So here is a sigma I from 1 to n, and then f x I, the dividing point, plus g x I. Okay, this is the integral function, right? And then times delta x. That's the definition. And remember this. So here is the summation. The sum of summation, we can do what? We can separate with the sum of summation, which is limit m approaching infinity. We can get a 2. So how to get 2? We get a sigma I from 1 to n. The first part is xi times delta x plus the second. Okay, the limit are going to use the limit rule, so we can separate the limits into 2 limits. I ignore one step. Okay, just. And then now here is sigma I from 1 to n is g xi times delta x. Okay. And you know, this is the summation rule. We use summation rule. Summation rule, and also the limit rule. Okay, it's separate. Separate. So you see, this is a Riemann sum for f. This is a Riemann sum for g, right? So we have a 2 integral. So use the limit definition. The first is a to b fx dx. The second is a to b gx dx. Okay, so this is the definition. This is the proof. It's easy to prove if you can use the limit definition. So now we can move to these questions. Okay, so these integral functions, we look at the integral functions. This is f, right? So we can say this is f. Okay, that means what? Fx equals 1. So f plus g, right? So this is a g. So g equals this function 9 minus x squared. Now we can use this property to separate into two. If I separate it, do this way. Okay, I just I put it here. Okay, so the first is negative 3 to 0, 1, or you say fx. Okay, dx. Plus the second is negative 3, 0, gx, as I wrote this. Okay, so the 9 minus x squared and the dx. Okay, that's use the property, right? So we use the property, we can separate into two. We calculate it one by one. In terms of area. What is this? The function. I do this here. This function is I use the red color. This function is fx equals 1. And the integral interval is negative 3 to 0. I draw graph. And this graph should be like this, okay. Negative 3, I put a negative 3, 1, so 1. And the function is this, right? However, the integral is only from negative 3 to 0. See, I highlight. And this is 1. So this area is the first integral. So we can find out what is the area, right? This is positive. This is positive because it's above x-axis. So the area equals this rectangle, right? So rectangle, we can say this is easy find. So this is a rectangle. The area of rectangle is 3 times 1, right? It's 3 times 1. What we get is 3. It's easy. So this one we done, right? So this we done. So then we move to calculate the area of this. So you do the same. So this is gx, right? So it's already here. It's gx equals 9 minus x squared. What is this graph? It's better to change this to y. So y equals the square of 9 minus x squared. If you are familiar, this is semicircle. Okay, this is semicircle. Y. I square both sides. Y squared equals 9 minus x squared. Plus x squared, what do we get? X squared plus y squared equals 9. This is a circle, right? However, y is greater than 0 or equal to 0. So that's a semicircle. If I draw the graph, it's like this. And this is a semicircle. However, this radius is negative 3. This is 3. So this is also 3. And now look at the integral negative 3 to 0. Negative 3 to 0. Under the curve is here is the 1. We need. Of course, we know the area, right? So if we calculate the area equals what? Is a quarter of the circle, right? A quarter of the circle. The circle is pi times r squared. And the do calculation is 9 pi over 4. Yeah, you done. This area and put it together. What do we have? Put it together. The first is 3. The second is 9 pi over 4. Yeah, this is already. If they did not ask you to approximation, this is the exact answer. Thank you.